Hello, Geometry. This lesson is titled Conditional Statements. Well, the first question to ask yourself is, what is a conditional statement? A conditional statement is an if-then statement. If this happens, then that happens. If I do this, then this will occur. If you get that, then you get this. It's an if-then statement. So something has to happen for there to be an effect. So cause and effect. If this happens, then another thing will occur. Now the first part is the if side of the statement. Now the if side of the statement is called the hypothesis. It's the if section of a conditional. So again, you first have to start off with a hypothesis. If something occurs, then what's going to happen? The conclusion is the then section of the conditional. Okay, so again, hypothesis, if something happens, the conclusion, then this will occur. So hypothesis, then conclusion. Okay? Now you're going to have to identify the hypothesis and conclusion of a conditional. Well, it's quite simple. You just take the if side, and that would be our hypothesis. Okay? So again, the hypothesis is the section right after the word if. So if, hypothesis, a student does all of their homework. Well, then what happens? Then we have our conclusion. The student will receive a higher grade. So that would be our conclusion. Okay? So notice when I underline them, I did not underline the word if and then. Because the hypothesis is the section right after the word if. A student does all their homework. The conclusion is right after the word then. The student will receive a higher grade. And that will come into play later on in this lesson, that we do not underline the word if and then for the hypothesis and conclusion. Okay, now we need to write a sentence as a conditional. What if it's not written as an if-then statement, but just a regular sentence? You're going to have to be able to rewrite the sentence as a conditional. So the first one says, professional baseball players receive high-paying salaries. We can all agree on that they do. So we need to turn this into an if-then statement. That's what a conditional is. So here's the example I came up with. If a person is a professional baseball player, then the player receives a high-paying salary. Okay, again, if, then for a conditional. Now you might have to add some words to make the sentence make sense. So again, we added like the word a person. If a person is a professional baseball player, then the player receives a high-paying salary. So that's how we turn a regular sentence into a conditional. Again, if, then. Okay. Now, what is a counterexample? Just like we learned a couple sections ago, a counterexample is, can you think of a situation that the conditional is not always true? Okay? So here we have one. It says, if you are a professional athlete in Charlotte, then you play for the Panthers. Now, that could be true, absolutely, but a counterexample is a situation where that statement is false. The conclusion is false. Well, we know that not all professional athletes in Charlotte are Panthers. What we could say is the athlete could play for the Hornets. So notice again, the hypothesis stays true, or not true, but we still have the hypothesis that the person is a professional athlete in Charlotte, but here the conclusion would change. The athlete could play for the Hornets. So they could be on the NBA team instead of the NFL team. Now notice when I wrote the counterexample, I did not write it as a conditional. When you're writing a counterexample, you just give a statement, not an if-then, but just give a statement in which you can prove that there are times when your conditional is false. So again, if you're a professional athlete in Charlotte, then you play for the Panthers. Well, no, you could play for the Hornets. Okay? So that is an example of a counterexample. Let's go on to the next page. Venn diagrams. Now, what is a Venn diagram? Again, I'm going to have to draw here, so please pardon my handwriting here. A Venn diagram is basically taking a conditional and drawing it into a picture, or, like the word says, a diagram. Now, usually people use boxes or circles, but that's okay, either one you want to use. And what we're going to have is we're going to have one section inside of the other. Now, the most basic thing I can say is that the inside what we have our oval here, so the inside of the oval, which is inside of the box, is where you put your hypothesis. Okay, so again, we put our hypothesis on the inside of, therefore, on the outside of the oval, but still inside the box is where we put our conclusion. So, the situations when it's a hypothesis, that will also fall under the conclusion. So that is how we set up our Venn diagram. So let's actually draw a Venn diagram with a specific example. Here it says if you drive an Accord, then you drive a Honda. Well, the reason why the hypothesis goes in the middle is because not all Hondas, conclusion, are Accords, but every single Accord car model is a Honda. So when we draw our diagram here, the Accord would go on the inside. You know what, I'm just going to type. It makes it easier to read. And there we have it. Again, all Accords are Hondas, but not all Hondas are Accords. So the hypothesis will go on the inside, the conclusion will go on the outside, but still within that box. Okay? This is how we draw a Venn diagram. Now, let's talk about a word called converse. Now, we're not talking about the shoe. Okay? We're not talking about Chuck Taylor's. A converse is when a new conditional is, forgot the word is. A new conditional is created by switching the hypothesis and conclusion of an original conditional. Okay? So again, we take the hypothesis and the conclusion of a conditional and we swap them, and that is the converse. Now that's why I said on the first one, when we talked about the conditional in the first place, why we didn't underline the word if and then. Because you don't switch the words if and then, you switch the sections in front of them. So here we have, write the converse of the conditional statement. If a shape is a triangle, then it has three sides. And again, the hypothesis here is a shape is a triangle, and then the conditional, it has three sides. So what we're going to do is we're going to swap positions. Now, when you do that, you do have to consider slightly, you might have to modify the wording to make it make sense, because the conditional itself has to stand alone as a logical sentence. So, what we came up with is, if a shape has three sides, then it is a triangle. Okay? So notice, if I were to just switch it exactly how it's written, it would say, if it has three sides, then a shape is a triangle. Well, when you swap positions, you have to consider what we are talking about when we say it. So, we write, it is the shape. So, if a shape has three sides, then it is a triangle. But notice the hypothesis and conclusion are swapped, and then again you might have to just modify a little bit on the wording to make it a logical sentence there. So if a shape has three sides, then it is a triangle. Now what you're going to notice is that not every converse, when you write it, is going to be true all the time. So here it says, write the converse of the conditional statement, determine the truth values of the original conditional and its converse. Here it says if two lines are parallel, then the two lines do not intersect. We know that to be fact. Parallel lines do not intersect. But what is it going to be true when we write the converse? So the converse is, if two lines do not intersect, then they are parallel. Now the question is that always true? Well, it sounds somewhat true to begin with, but then we have to remember what we learned before is that skew lines do not intersect, but they're also not parallel. So in this case, the original conditional is true, but the converse is not always true. So that one is actually false, because we can come up with a counterexample. Skew lines do not intersect each other, which fits the hypothesis, but it does not fit the conclusion. They are not parallel. Okay? So that is how we write the converse and then determine the truth values. One may be true, but the other may not be. Sometimes they are both true, and sometimes they're both false. But we usually do start off with a true conditional, and we're just checking to see if the converse is also true. Okay? Now here it says, write the converse of the conditional statement. Again, we're going to determine the truth values of the original conditional and its converse. Now this one says, if you love God the Father, then you love God the Son. Well, this is a Christian school we teach at, so we get to talk about the Lord. So this is our conditional. If you love God the Father, then you love God the Son. Now, if we were to flip that around, we would get, if you love God the Son, then you love God the Father. Now the question is determining the truth values. And according to Scripture, 1 John chapter 2, verse 23, it says, whoever denies the Son does not have the Father either, but he who acknowledges the Son has the Father also. So, there is no Father without Son. There's no Son without the Father. So, if you love God the Father, then you love God the Son. Biblically, scripturally, that is true. And if we flip that for the converse, if you love God the Son, then you love God the Father, that must be true as well. You can't have one without the other. So, the original conditional and its converse would both be true. Okay. Now, finally, for our last few examples, let's talk about notation and symbols. Here we have a conditional. If an angle is a straight angle, then its measure is 80. Now, what you're going to see is, notation-wise, we can just talk about, in general, a condition in general, not even specific, what the hypothesis or conclusion has to say. Here it says, if an angle is a straight angle, then it measures 180. What we can say is that P is an angle is a straight angle. Q, its measure is 180. So what you will probably at times see is that if P, then Q. So we can write the conditional such that if P, then Q. Okay? If P, then Q. Now let me go ahead and change that to type text so you can understand that better. If P, then Q. So that is some notation there, but also with symbols, if you were given just the letter P and then with an arrow Q, that's saying the same thing. If P happens, then Q happens. Okay? Now the converse here, again, what you would say is if Q happens, then P happens. Okay? If Q, then P. So this one right here, this says if P, then Q. This one is saying if Q, then P. So the converse would be if the measure of an angle is 180, then it's a straight angle. But again, right here, I just want to focus on notation here, what that is saying. Again, if P, then Q in writing, but with symbols, all you would have to write is P, then an arrow going to the right, then Q. And then same thing with the converse, just switch the letters, Q, then P. Okay, so again, conditionals, converse, that is the biggest point of this lesson, conditionals, converse. Please understand that when you switch the hypothesis and conclusion, you don't take the words if and then with them. You leave the words if and then where they're at. And sometimes, again, you might have to modify the wording of it when you switch it. So, good luck with that.